we're going to set up two things here, problem 1 and problem 2. They're kind of separate on your notes, so make sure as you finish 1, you move on to 2. Problem 1 is the value of a computer. What do you think happens to the value of a computer not even looking at it? After you buy your computer, decrease, like, because newer computers are just like always better, right? New ones are better. So you're going to look at the purchase price, when x is 1, the meaning of f of 1, how is it changing, and then you're going to write the function. For problem 2, there's 2 different graphs. You're going to write a function for each and then examine what the value is when x is 5. So we're kind of putting everything we've been doing together here. Some advice for number 1 is make a table. That's just some advice I have for number 1. So 8 to 10 minutes here with your partner. You're going to get after number 1 and number 2 before we go over it. All right. So for 1A, who can tell me how much that computer costs from the store? Vinny. How do you know that? Yeah, because at input 0, it was 400. We know it because bam, right there. Who can tell me what the value is when x is 1 and how you know? Elsa?
200 because it's decaying by 1/2.
200. You can see a decay factor of 1/2, and you kind of have to do like a little work right there to say it goes down from 400 to 100. What had to happen by division twice? Do you see you can't like divide? You can't like find the difference and divide. Did anybody get 250? 250 is the most common wrong answer there. Okay, that's good. So who can tell me what f of 1 means then, in context? JP? Price of computer after 1 year. Cool. And who can tell me how the value is changing each year? Sean?
It's decreasing by 1/2 each.
Yeah, we've got a decay factor of 1/2. We found that right here when we found 1 200. Who can help me out with the equation that defines f? Maddie? There we go. Starting out at 400, going half each time. And then will it reach 0? No. Well, we're gonna tighten that up and say theoretically. No. Because eventually nobody's going to pay money for it. It's going to be like worth less than a penny, right? So theoretically, no. Near the exponential growth function, I would like somebody to write down the function they got and then explain how they got it. I don't know.
For this one?
Yep. I already changed the color, so so it's for number 2. Yep. So for the second one there, we got y of x.
Oh, I don't have enough room.
Yeah, you can
No,
write
I
out
really-
underneath
okay.
it. You can just write underneath. Okay, so it looks like a 5 times 3 to the x. Y of x equals 5 times 3 to the x. So what that would mean is a y-intercept of 5. Is that good? Yeah, y-intercept of 5. Is it times 3? Times 3, 5 to 15. Cool. So I'm going to rewrite it right under so it's on, or right here maybe. Y of x equals 5 times 3 to the x. All right, the last one on there. I'm looking for the function of that one. Any volunteers to write the function down? Looking around. All right, Brendan. Got g of x. Okay, what's our initial value? Is 20?
Yeah.
Did you just start that too and go bottom up?
Yeah, that's how I've always done it.
Interesting. And we have a decay factor of 1/2 each time. There is the function. Thank you, Brendan. And thank you for sharing your interesting twos with us.
After 2 years, it'll be 0.
Last thing we need to do. We need the functions when the value is 5. So I'm going to slap a 5 in for that x. I'm going to slap a 5 in for that x. When I slap it in up there, I've got y of x, or y of 5, equals 1,215, I think. No. Yeah, that's right. And then down here, I got 5/8, I think. Did anybody get 0.625? That is 5. Do you know the trick for eighths? An eighth is a half of a fourth. A fourth is 0.25. So each eighth is 0.125. I go to a nice fourth, like 4/8, which is half. So if that's 0.5, another eighth is 0.625. 4/8 to 5/8. Anyway, I use I use each eighth being 0.125, and then I use the nice 4s to get there. Cool.